If you are live streaming, they are running a few minutes late, so I'll be getting started in about 2 or 3 minutes. So just hang tight.
Professor, they can see you now.
Awesome. Can everybody?
Say again?
Ivan, could you mute the sound on your end? There's a little bit of a reverberation.
Okay.
Great. And then you'll just have to unmute if you need to tell me anything. But let's get rolling. So good morning, everybody. Welcome back. I hope you guys all had a nice weekend and are attempting to stay healthy. Thank you for all the well wishes last week. I'm feeling much better now. Just as a reminder, please make sure that your mask is up and over your nose so we're not spreading germs around. So a couple of other course-related reminders. So today we are going to finish the last section from chapter 1. And so you have your mini quiz on Wednesday, and then we have our chapter quiz next week on Monday. And so for the chapter quiz, that will show up on Moodle. It'll be open for the full 24 hours on Monday. So it'll open at 12:01, so right after midnight, and it'll be open until 11:59 p.m. So you can take it at a time that's convenient to you. You have 1 hour to complete it, and there's 10 questions, and they are multiple choice, just like the mini quizzes. So a good way to prepare for the chapter quiz on Monday will be to look at your past mini quizzes, take notes on that, to go through the review that's posted on Moodle called the Chapter 1 Review, and to look over any homework questions that you may have had a hard time with. Just like the mini quizzes, it's open notes, so having good and organized notes will be helpful. And if you've done all those things, then you should be in pretty good shape for that quiz. So I'll talk a little bit more about that on Thursday when we start chapter 2, but that's sort of what's coming down the pipeline. So as I mentioned, today we are going to be doing our last section on periodic functions. And so this week, you will notice from the email that I sent that William is doing reviews on sine and cosine. So that is related to what we'll talk about today. But if it's been a while since you took pre-calc and you don't remember things like the common values of sine and cosine in radians, things like that, then the review might be helpful. And I will post that after the review on Moodle. Under the Getting Started tab, I've been posting William's recordings of those reviews that have been happening. So let me switch on over to the doc cam and we can get started. Put that over here. Okay, so today we are going to talk about periodic functions. And by definition, a periodic function is a function that repeats its values in regular intervals, and we call those intervals periods. So when we model something, if we notice a pattern and it's repeating, then we know that that function is periodic. Now, this is really helpful in math because if we have a periodic function, that helps us predict what will happen in future instances because we know that from the repetitive nature that the same things will occur again and again, so we can predict what will happen later in time. So here's just a couple of pictures of some periodic functions that you can see. So notice here that we have sort of this solid line. This is like one period of this function, but then it repeats the same pattern over and over again. So one way that we notice periodic functions is by plotting the data or the picture of what's happening to see visually that it looks like there's a pattern that's repeating itself. The next one you can see, is a little bit longer of a period before it starts again, but it's repeating again and again with sort of the big bump and then the little bump and then the big bump and the little bump and then the big bump. So if we were going to try to detect what would happen next, we know it's going to be this little bump because it's repeating. Now, data isn't always super clear that it's periodic. So this is just an example where the data looks a little messy, but if you look at it long enough, you can see that there's sort of repetition. You can see up at the top this sort of double hill, and then the double hill, and then the double hill. So these are all just examples of periodic functions, you know, where we look at them and we see that something is repeating. Okay, so this is just sort of the visual representation. So what sorts of information do we want to get from periodic functions? Well, there's two key pieces of information we need to talk about periodic functions and to do predictive analysis of these types of functions. So the two sort of big things we're going to be talking about are something called amplitude and something called the period. So first, let's talk about the amplitude. So the amplitude tells us how far we vary from the midline to reach the extrema. So what does that mean? That means if we had a function and we could figure out where the middle value of the function was, the amplitude would tell us how far we go to reach the maximum or the minimum. So it's sort of hard to conceptualize what this means, but for any function, if you were to draw a line horizontally straight through the middle, the amplitude is how far away you are from the max or the min. It's the same value in either direction. Now, because we talk about the amplitude being in either direction, so from the midline to the max or the midline to the minimum, we always report it in absolute value. So we'll talk about that a little more concretely when we write down formulas later, but the amplitude is always reported as a positive value because it's the amount you vary from the midline. So it doesn't really make sense to have a negative value there. So the way that we figure out what the amplitude is for any function is we're going to take the max and min dependent values, so the y values, we're going to determine the max value, and then we're going to subtract off the minimum value and divide by 2. So if we have a function that has a maximum of 10 and a minimum of 1, we would do 10 minus 1 divided by 2. Okay, so this will work to always find our amplitude for a particular function. So notice that the amplitude has to do with sort of the up and down of the function, right? The max and the min of whatever we're looking at. The period is going to look at the horizontal values. So the period is the amount of time or distance in terms of the independent variable. So we're looking along the horizontal axis that it takes the function to complete one cycle. So what that means is how long does it take the function before it begins to repeat? Does it take 4 units? Does it take 6 units? How long until we start to repeat? So we're going to look at some examples. We're going to sort of look at those 3 pictures we looked at before and try to figure out the amplitude and the period based on the graphs. So we'll do the first one together, and then you'll have a chance to try some here. And so I tried to sort of mark on these graphs because, as you know, they're kind of hard to see, but each of these hash marks is 1. So we can kind of figure out where we are. So that's 3, and then down here is -1. So here we're just approximating, okay, which means it doesn't have to be perfect. We're just trying to get a good approximation. So for the amplitude, we're going to start by looking for the maximum and the minimum values. So the maximum values happen every time we reach one of these peaks. And so the maximum value here is 3. Then we want to subtract off the minimum value. So we come down here to every time we have one of these little loop-de-loops. Okay, and that's approximately -1. So 3 minus -1 divided by 2. Be really careful with negative values because if you subtract a negative, the minus and the negative cancel out. So we actually have 3 plus 1, right, which is 4 divided by 2, which is 2. So what that tells me, I'm going to draw in the midline here. So the midline here happens to be at 1, which is not something we're finding, but it's something I want to point out in terms of the amplitude. This is exactly the middle of the function. The amplitude says that we're going to go by 2 units to get to the maximum and 2 units to get to the minimum. Okay, so that's what the amplitude is telling us. It's telling us how far we go from that midline up to the max or the min. That's what we're calculating. Okay, now for the period, we want to figure out how often this function repeats. So that means we have to figure out where the pattern starts and stops. Now you can pick sort of any place for it to start and stop, but I've sort of created this solid line to show one version that I saw. You could go from peak to peak. You could go from min to min, right? Any of those are going to give you the same value. So here, I want to figure out where my pattern starts based on where I'm cutting it off. So here, that's -1, -2, -3 is where that crosses through over here. And then to the right of the origin, I have 1, 2. So this is +2. So from -3 to +2 is 5 units. So it took 5 units before my pattern started again, right? So my period here is 5. So again, the amplitude is looking at the vertical things that are happening, and the period is looking at the horizontal things that are happening. Okay, so I'm going to give you one to try. We're going to look at these two, and I'll mark some values to make it a little bit easier for you to see, hopefully. And we're just trying to figure out the amplitude and the period. And so again, this is an approximation, so it doesn't have to be perfect. That's the value of 2, in case you can't see that. And then -2 is down here. And then this is counting by 2. So this is 2, 4, 6, 8. Okay, so I want you to try to approximate it. Again, it doesn't have to be perfect, right? So your approximation might be slightly different from somebody else's, and that's okay. And then for the second graph, let's see if we can get them both on screen at the same time. We're going to try to approximate on this one as well. So this is 11, 12, 13. This started at 10. And then on the up and down axis, right, this is 5. This is -5, this is 0. So 1, 2, 3, 4. So these are sort of odd approximations because these are from functions that have some weird data, but take a look at it. I'm going to give you 2-3 minutes to try to figure out if you can approximate the amplitude and the period for each of these two functions. Okay, so try it out, see what you can come up with. Feel free to check in with someone next to you. If there's TAs there, they can walk around and help, and then we'll go through it together. All right, take about 30 more seconds to finish up whatever part you're working on. All right, so let's go through these. So again, these are approximations. So if you didn't approximate exactly like I did, that's okay, as long as you're relatively close to what I got, okay? So to do the amplitude, we need to figure out this maximum value and the minimum value, okay? So for my maximum value, I picked 2.5. If you picked anything between like 2 and 3, you're on the right track. Okay, you may have said 3, you may have said 2.75. That's totally fine. Then for my minimum, I called that negative 0.05 or 0.5, negative 0.5. So if you said negative 0.5 or negative 1, you're good to go. And then from our formula, we have to divide by 2. So again, we need to be a little careful because we're subtracting off something negative. And so we want to use parentheses to show what's going on. So these cancel, that becomes a plus. So I have 3 over 2. So my amplitude is approximately 1.5. Okay, so anything between sort of 1 and 2 is a good approximation for this amplitude. Now for the period, again, we need to figure out where our pattern starts and finishes, and you can do that anywhere on the graph. For me, I just started at the origin because I thought that would be the easiest way to figure out where it repeated. And at the origin, we see we're at a maximum. So that's at 0. And then if you look at this and you just see where it goes until it reaches that maximum again, okay, I said that that maximum happened again at 6. So from 0 to 6 tells me that I'm going to repeat every 6 units. But again, you don't have to pick the same place to determine the period that I do. You could have gone from, you know, the top of the small bump to the top of the small bump, right? And you're still going to get 6 going that way. So as long as you're finding where you start and then where that start begins again, you should get approximately 6 for how often it repeats. Okay, so let's take a look at the second one. This one's a little more scattered. It's a little bit harder to see that it's a periodic function, and it's harder to see in general because it's printed so lightly. But again, for the amplitude, we're trying to figure out the maximum value. So looking at the picture, the maximum value kind of happens at one of these 3 peaks, right? They're all the same. So we're approximating what the value is there for that max. So I called that 4. And then for the minimum, you see we get this sort of really big dip. Okay, and so here, if we bring that over, I called this negative 4. And again, if you didn't use 4 and negative 4, but you did something relatively close, that's totally fine. If you did like 4 and negative 3.5 or 3.5 and negative 4, like as long as you're close to that. And then remember, we have to divide by 2. So here, 4 minus negative 4 is 8 over 2, gives us an amplitude of 4. So I'm saying that my function varies by 4 to get from the midline to either the max or the min of the function. Now for the period, we need to figure out when it repeats. I typically like to start at the origin to see when it then repeats itself. So this is very bumpy, so I'm going to try to trace over it. But to me, that's where we start repeating the pattern, right? So I started here, and then I got here, and then it starts again to do the same thing. So I'm trying to approximate how far I went in the dependent direction. So here, this was 10. This I don't know, it's probably 11.5, 11.6, somewhere over there. So my period from 10 to 11.5 is approximately 1.5 units. And here, that's in years, right? So again, you're just trying to figure out about how long it takes to repeat in the dependent direction. And again, because I started at 10, I went from 10 to 11.5. That is 1.5 units. I don't want to write 11.5 because I wasn't starting at 0. I was going from 10 to 11.5, which is 1.5 units. So that's just sort of the general way that we think about and talk about amplitude and period. In this class, the majority of the time, we are going to be looking at some pretty specific periodic functions, which you may have a guess at what they are. And so we're going to dive a little bit deeper and talk about those particular functions. Okay. So the first function that we're going to talk about is the sine function, okay? And one thing that's really, really, really important in this class is that whenever we do any calculations with sine and cosine, we always have to be doing it in radians. So we are not studying sine and cosine in terms of triangles because we're not doing any geometry. We are instead looking at it as a function, which means that we are evaluating things in radians. So if you are doing homework problems with sine and cosine and you are getting the wrong answer, your calculator may not be in the right mode. So make sure that your calculator is in radian mode whenever you're doing anything with sine and cosine. Okay, that being said, so let's talk about some of the features of sine and how that plays into what we know about periodic functions. So the first thing is sine is a function that repeats itself, right? So once your function starts, it continues to do the same thing over and over forever. Sine goes on forever in both directions, okay? And so it is a periodic function because we can predict what will happen next. So in terms of sine, the way that it is done sort of at its most basic value is that our amplitude is going to be the maximum minus the minimum divided by 2, but you probably already know what it is just from having done sine and cosine type stuff before. So the maximum value of sine is 1. The minimum value of sine is -1, right? So sine always varies between 1 and -1, which means our amplitude is 1 minus -1 divided by 2. So 2 over 2, which equals 1. So we vary from the midline of sine by 1 in either direction to get to the max and the min, okay? Some other characteristics about sine that are going to be helpful. If you look at where sine is in terms of the origin, okay? Sine typically starts off as an increasing function, so it's going up, and it also starts at the midline of the function, right? So if you think about the midline, it's a line that crosses right through the middle. Sine starts at the midline. This is going to be important because later we're going to be trying to look at models and determine if they're sine and cosine. And so we're looking if we start at the midline of the function to help tell us if it was sine, okay? So we know that the amplitude is 1. Now the period of sine, so how often it repeats, we start at 0 and we come over here and you see we're a little bit past 6. So it turns out that the period of sine is 2 pi. Okay, so remember that pi is approximately 3.14. So that means 2 pi is 6.28. So you can see we're a little bit past 6. And so every 2 pi units, sine will start again and repeat. Okay, so that's the sine function just in terms of its basic characteristics. We are also going to look at the same thing for cosine, and then we'll start comparing the two of them. Okay. So for cosine, we can see that it looks very, very similar to sine. it turns out that cosine and sine are the same function shifted by pi over 2, right? So it's going to have all the same characteristics as sine, but the difference is where we start and where we end. So let's start by talking about the amplitude. Just like sine, cosine has a max value of 1 and a minimum value of -1. So the amplitude, 1 minus -1 divided by 2, which is 2 over 2, gives me an amplitude of 1. So we're varying by 1 to get from the midline to the max and from the midline to the min. Okay, so we know that sine and cosine both vary between 1 and -1. And then the period here, right, is also going to be from our 0, from peak to peak, a little bit past 6. So cosine also has a period of 2 pi. Now, what I want you to notice about cosine, okay, is that at the origin or at 0, cosine starts at a maximum, right? So it starts up at 1, comes back down, and goes back to the maximum. So when you're looking at a function and you are trying to figure out, is it sine or is it cosine, right? If you look at what's happening at the origin, if your function starts at a maximum, you have cosine. If it starts at the midline, it's sine, right? Later on, we'll talk about what happens if it's rotated and things like that. But this is one characteristic that you sort of want to file away for later, okay? So cosine, just like sine, has an amplitude of 1 and a period of 2 pi, okay? So the first thing we're going to do is we're going to apply some of our graph transformations, okay? So here, the first function here, we have 6 sine x, and the second one we're talking about 3 sine x minus 2. So what I want you to do is think back about what this means from when we did 1.8 last week. What happens if we multiply this function by 6? What will it look like? And for part B, what will the function 3 sine x minus 2 look like? So for both of these, the graph that you see is the graph of sine. So that's what we are transforming to see what the difference looks like. So I want you to try this, okay? I want you to graph, if you don't have the graph printed out, just graph a quick sine x, right? You can just do 0 to 2 pi if you want. But then on top of it, graph 6 sine x. So remember, if you multiply by a constant, it's going to impact the vertical direction, okay? And then for the second one, you start with a sine function, and you're going to do 3 sine x, which you're going to do something similar to what you did in the first one, but then also minus 2. So how does that minus 2 impact the graph? So think about how that's going to change the graph and draw the new graph on the same axes as the sine graph, okay? So try it out. If you have a calculator, a graphing calculator, you can also check your solution by graphing sine and the new function on the same axes to make sure that they're the same. I'm going to give you about 3 minutes to try it out, see if you can get those graphed, and then we'll look at them together. All right, take about 30 more seconds to finish up whatever part you're working on. All right, so let's take a look at what these graphs are going to look like and how we can then transform them into their new function. All right, so here let's start by looking at 6 sine x. So the sine x is the one that was graphed originally. If we are going to do 6 times sine x, that means that we are going to do a vertical stretch by 6 units. So instead of going up to a peak of 1, we're going to go up to a peak of 6, right? So this max value of 1 goes up to a max value of 6. Okay, the shape is going to stay roughly the same, but the zeros are going to remain the same because 0 times 6 is still 0. So that helps us figure out where we have to come back to. Over here, we had a minimum value of -1, which now comes down to -6. So we should have stretched by 6 in both directions. Now, for the second one, I did sort of 2 versions of this. So first I did the 3 sine x. I said, what's going to happen if I multiply everything by 3? So that's what I did in green here. So that, like the 6, is going to stretch the function by 6 units. So that means that our 1 is going to go up to 3, that our -1 is going to go down to -3. So that's what I did first. I said, okay, what is the impact that the 3 has? But then I also needed to do this -2. So when you add or subtract a number outside of the function, it moves the function either up or down. So if you subtract, that means you're going to move your entire function down 2 units. So after I stretched by 3, I had to move every single value down by 2 units. So the way that I did this is I took my known values. Everywhere that there was a 0, I moved it down to -2. Right? And I drew in a dot. And then at my peaks, I also drew in the dot. And that gave me the map to draw this 3 sine x -2. So you can see that there's a difference of 2 units the entire time underneath the 3 sine x graph. So I moved it down by 2 after I stretched it by 3. Okay, so that's what that one looks like. I'm going to have you try one more just for the sake of interesting relationships. And we'll see what shakes out here. So sine of x plus pi over 2. So I want you to remember that when you add or subtract a value inside the parentheses, that's when you move things left and right. Okay, and it's the opposite of what you think it'll be. So since we have plus pi over 2, we are trying to shift this left. So I want you to think about how you can take some values and move them left. Again, it's an approximation, so just try your best. You may have a sense of what's about to happen when you try to graph it, but I'm going to give you 2 minutes quickly to try to graph this particular function on the same axes as sine of x, and then we'll go through it together. All right, take about 30 more seconds to finish up. All right, so when we shift this function left by pi over 2, we are taking these values and moving them left. So the maximum value, which happens to be at pi over 2, gets shifted. So this point gets shifted right to the origin. And when that happens, every other point gets shifted as well. I will tell you that I found this incredibly hard to draw, even though I knew what it was supposed to look like. When I shift sines and cosines left and right, I have a hard time with like the bends of the curves. So if you found this particularly tricky, you are not alone. So here, what you're supposed to notice is that when you shift it left pi over 2, you end up with a cosine graph. Okay, so the sine graph starts off, the midline comes up, goes down. When you shift it, you end up with the cosine picture because sine and cosine are the same function shifted by pi over 2. Now, that can make some of the work that we're going to do a little confusing because a lot of the things that we're going to be doing is trying to figure out how to write a model for a function that we are seeing in terms of sine and cosine. And so the reality is when we do that, there's an answer in terms of sine and there's an answer in terms of cosine that would be equal but shifted. So in general, we are not going to be turning sines into cosines by shifting, right? Because if you can shift it, you might as well just call it cosine. But it's important to know that that is how they are related, okay? So how do we put this all together to start to really work with it? This idea of stretching and shifting and amplitude and period and all of these things. So we have what's called the general form, okay? And the general form for sine and cosine look like this. So we have a sine of bt plus c and a cosine of bt plus c. So within these two general forms, for sine and cosine only, right? This is the general form only for these functions. The amplitude of your function is always going to be the absolute value of a. So whatever the a value is, your amplitude is going to be the absolute value of this. Why is that true? Well, for two reasons. First, because sine and cosine vary between 1 and -1, that scalar of 1 helps you, if you multiply a number by it, it just scales it by that same amount, okay? The other reason is because sine and cosine are symmetric about the x-axis, which means it varies the same amount above as below. So if we want to find the amplitude of something in the general form, we can just take the absolute value of a, okay? We're going to skip the period for a second and come back to it. We'll talk about the vertical shift first. So over here, we have this plus c. We know from our work on transforming graphs that if you add a number at the end of a function, it is going to move that function up that amount. And if it's negative, right, if we had like minus c, it would move it down that amount. So just the same as before, that c is called the vertical shift. It tells us how much up or down our function is going to move. Now, the period. This is where things get a little confusing for a lot of people, okay? So remember from before, the period is how long it takes your function to repeat, right? So on a sine graph, that was 2 pi, okay? How is that related to our general form? Okay, well, it's related to this variable b right here, because what b does is it stretches a function horizontally or it shrinks it horizontally. And so we have to scale to relate the 2 pi, which is the normal period of a sine and cosine, and relate it to this variable b. So if we're multiplying by b, how does that impact our period? Well, it turns out from the general form that the period is going to be 2 pi over b, okay? So I want you to consider just the general function of sine x. So for sine x, your b would be 1, right? There's an invisible 1 there. And so the period would be 2 pi over 1, which is 2 pi, which we know to be true. If, however, we had sine of 2x, my b equals 2. And so now my period would be 2 pi over 2. The 2's are going to cancel. And my period is going to be pi. So that means that by multiplying a 2 in here, it shrinks my graph because I complete the entire period by pi instead of 2 pi. So there's 2 ways we do this. Sometimes we have a general form and we have to determine the period. So that's exactly what I was doing here. Other times we have a graph and we are trying to determine the general form. And when you start with a picture, you have to fill in the period on this side of the equation and solve for b to put together the formula. So it's a little bit tricky to get used to, but we're going to practice it and then hopefully it'll make a little more sense. Okay, so these are the 3 pieces that we need to solve for when we're trying to set up a general form. If we have our A, we can figure out the A part, right? The period helps us find B, and the shift will help us find C. So we know other ways to talk about this, right? Because we know the amplitude is the maximum value minus the minimum value divided by 2. But we need to start putting this all together. Okay, so this is what we're going to do. We're going to start with this top one. Okay, we are going to try to find a possible formula for this function based on the graph. Okay, so what we're going to do here is we're going to do this one together, and then I'm going to have you try 2 other ones to try to get used to it. So I'm going to walk you through the steps of what this might look like. So typically what we're going to do is we're going to be figuring out these things. So we need to know the amplitude. We need to figure out the period and the shift, but we also need to figure out, is it cosine or sine, right? So these are sort of the 4 pieces that we need to put together. Some of them are easier than others, right? So let's see if we can figure out from this some of these pieces. Now, I tend to start by figuring out, is it sine or cosine, and build from there. So remember that before when we were looking, I said sine starts at the midline, right? So here, if I look at what's happening at 0, this is the midline. It doesn't start at a max or a min, right? So this is going to be a sine graph, but you may notice, right, that instead of starting off by increasing, I start off by decreasing. So this is actually a rotated sine graph, which is a little tricky. Okay, so I know it's sine because it starts in the middle, but since I start off decreasing instead of increasing, I know that I'm dealing with a negative sine graph, but I still need to transform it to match the amplitude and everything else. Okay, so let's start by finding the amplitude. So again, for the amplitude, we can do max minus min divided by 2. So my max value here is 3. My minimum value here is -3. So my amplitude is 3 minus -3 divided by 2. So that's going to be 6/2, which gives me 3. So now I have -3 sine x, right? Because I added in my amplitude of 3. Okay. The reason why it's negative, again, is because I've rotated it around. If I was going to report the amplitude from this, I would be taking the absolute value. Now I need to figure out what is the period, right? So if I look at this and I look at where it starts and where it starts to repeat, it's a little bit after 6. So that looks like 2 pi. So it looks like that has not changed from a regular sine graph. So I don't need to do anything in here because it has the normal 2 pi that a sine would have. If it was different, then I would have to do a little more work. And then the question is it shifted, right? Do I have a plus c or a minus c here? How do I tell? Well, one of the key ways you can figure it out is looking at if it varies between the same thing. So since it goes from 3 to -3, it hasn't been moved, right? 4 to -4 would be fine, 5 to -5. But if you had something like 2 to 7, where the number is not the same in the positive and negative direction, then it's been moved up or down. So how do we figure out how much it had been moved up or down? Well, you could take the maximum value and figure out what the new max is to try to figure that out, or you can sort of reason through it. So this particular function here, right, is 3 sine or -3 sine x. Now, these are tricky to do at first. You definitely get used to them over time, but we can check our answer. If you put this on a graphing calculator, you should see this picture. If you don't, then you probably missed something along the way. So it's a really good way to check your work. Okay, so I'm going to have you try the next one. So again, you'll need to figure out, is it sine or cosine? Okay, then from there, what is the amplitude? Has it been shifted? Try to reason through that. I'm going to give you about 2 minutes to figure out what you can figure out. Feel free to check in with someone next to you. Any TAs can walk around, but try this one out. And again, know that the first couple times you try this, it's not super intuitive, but it does get easy the more you practice these. Okay, so try it out. All right, take about 30 more seconds. All right, so let's talk about figuring this one out. So again, I encourage you by starting to think about whether it's sine or cosine. And so again, one of the key markers here is if your function starts at a maximum or a minimum, it's going to be some version of cosine. If it starts at a maximum, it's regular cosine. If it starts at a minimum, it's negative cosine. So here we can see at 0, our function starts at a max value. So I'm going to have cosine here is the structure that I'm building. Okay. So now I want to figure out the amplitude. So I'm going to take the maximum value, which is 3, minus the minimum value, which here is going to be 1, divided by 2. So 3 minus 1 is 2, divided by 2 is 1. So my amplitude here is going to be 1. So I have 1 cosine. Next, I'm going to look at the period. So here I started at 0 and I go to a little bit after 6. So nothing was impacted by the period. So B is still just 1. So far I have 1 cosine of X. Now, at this point, I know that it can't just be 1 cosine of X because cosine typically goes between 1 and negative 1, right? So something more like that, right? So I can see that this cosine has been moved in the upward direction. So how do I figure out how much it's moved? So again, one of the things you can do is you can just look at these maximum values to see if you can kind of figure out how much it's been shifted. Typically, cosine lives between 1 and negative 1. Now the max value is at 3, right? So instead of being at 1, it's been moved up to 3. In order to get from 1 to 3, I have to add 2, right? So my shift is going to be 2 units. There is another way to calculate the shift exactly. I'm going to tell you what it is, but I'm going to tell you why we have to be really careful about this. So the vertical shift, you can do the maximum Y value plus the minimum Y value divided by 2. Now this might look very familiar because this is almost the same exact formula that we use for amplitude. The difference is for amplitude, we do minus, and for the shift, we do plus. So we don't typically talk about this formula much because people get them confused, but as long as you can keep straight which is which, you can use this formula. Okay, so here, my maximum value, we said was 3. The minimum value was 1 divided by 2. So 4 divided by 2 gives me that vertical shift of 2, which means that my final function is 1 cosine plus 2. Okay, if you want to write in 1 for the amplitude, you can. You don't have to. Anything times 1 is itself, but if it helps you remember, that's totally fine. It's just a matter of which you prefer. But we have cosine of X plus 2. Okay, we're going to try one more of these to make sure we got this down. This is the majority of the type of things we'll be doing with this, is a lot of interpreting and determining the general form. So we want to make sure we understand it really well. This one's a little bit harder. Okay, so I'm going to give you about 3 minutes and then we'll go over it, but feel free to check with someone next to you. And of course, feel free to check on your calculator that your function gives you this same picture. Okay, so give it a try and then we'll go through it together. All right, take about 30 more seconds. All right, let's see if we can figure out all the parts of this one. So the first thing I want to point out is that this function at 0 starts at a minimum. So again, if your function starts at a max or a min, it's cosine. And if it starts at a max, it's just plain cosine. And if it starts at a min, it's negative cosine, because that means it was rotated, right? And by multiplying by that negative, it rotates about the x-axis. So negative cosine is where we're going to start our work, right? So now we want to figure out the amplitude. So here, my max value is 4. My min value is -4. So I have 4 minus -4 divided by 2. Again, be careful with your negatives. So we have 8 over 2, which is 4. So that means I have -4 cosine x so far. Now, let's talk about the period. So notice here that if you trace the graph, that the graph starts repeating a little bit after 3. It's safe to assume when you're working with sine and cosine that if you're a little bit after 3, that that's pi, okay? So the period here is pi. We have to use the period from the graph to figure out our b, right? Which is going to go in here with the x. So remember that the period equals 2 pi over b, and we are trying to solve for b. We know the period is pi. So we have pi equals 2 pi over b. We can multiply the b up and divide the pi down to give me b equals 2 pi over pi. The pi's will cancel, and that tells me that my b equals 2. So that means I have -4 cosine of 2x. So again, your b is going to go in there and multiply your variable, which here is x. The last thing I need to do is figure out if there's a shift. So if my vertical shift, I can do the max plus the min divided by 2. 4 plus -4 is 0. 0 divided by 2 is 0. So there's no vertical shift here, right? If you get 0, there's no shift. So my final function here is -4 cosine of 2x. And again, these always feel tricky at first, but they get easier with time. Okay, so we have one final example to try out here. This is a word problem that we are trying to convert into a formula. And so what I would like you to do is just give it a read, try it out, write down a couple notes about amplitude and period. I'll give you 2 minutes just so we have enough time to go over it, because I don't want to go over time, but see what you can figure out from these values, and then we'll quickly go through it. All right. So within this problem, there's a lot of important numbers here, but what we're really looking at is what are the max and min values that we get that model in this function. So my amplitude here, we're going to have 15 as our max and 9.5 was our min, divided by 2. That gives me 2.75 for my amplitude. Now, I plotted each of these values. I was told that time equals 0 is June. So I took all of these values and plotted it. And what I get from that is I see that I'm starting at a max and ending at a max. We know that that's cosine. So if our amplitude is 2.75, cosine of something plus something, my period here, right, is 1 year. So here we're talking about months. So if we're trying to figure out, how often I'm repeating, it's every 12 months. So my period, I'm going to write this down here, is 12 months. So I do 12 equals 2 pi over b. Again, I'm going to multiply the b up, divide the 12 down. I get 2 pi over 12. Which simplifies into pi over 6. And then lastly, I have to figure out the shift. So again, I can add my 15 plus 9.5 divided by 2, and that's going to give me 12.25. So here I'm going to add 12.25. So my function ends up looking like this. I strongly encourage you to think about all these pieces in the context of this word problem for future word problems and make sure you understand where all the pieces come from. Okay, so on Thursday, we'll do limits and continuity, and I will see you guys then.